Hey everyone, we are a group of students from BTech third year at DIICT Gandhinagar. We are making this tutorial as a part of our project of the course Software Testing and Quality Analysis. So we are a group of 5 students and I am Rishita Patel. We are making this tutorial for anyone who wants to learn TestNG and who wants to use this as a reference. TestNG can be used in different IDEs, but we'll focus on the Eclipse plugin part of the TestNG. We'll be demonstrating all the aspects of TestNG right from installation to pros and cons. TestNG is a newly developed testing tool inspired by JUnit. JUnit is a very widely used testing tool, but TestNG adds on its functionalities and broadens its range from unit testing to integration testing. Finally, let's make sure that you are prepared for viewing this tutorial. So you should be having a basic understanding of Java programming language. You should be knowing the text editor and how the execution of the program takes place. And you should have Eclipse installed in your computer or laptops. And finally, you should have a JDK of 7 or higher version on your computer.
I will be explaining you installation guide for TestNG in Eclipse. So first you need to open the Eclipse. As you can see, I have opened the Eclipse in my Windows. Then click on Help and Eclipse Marketplace. Just wait for the loading the things. Now search TestNG and click go. Where you can see TestNG for Eclipse. Now you can click install or select all the TestNG for Eclipse plugins. Press confirm. Press I accept the terms and license agreement and finish. You need to restart the Eclipse to use the TestNG in your Eclipse. Click yes. Now to see whether TestNG is installed or not, click on Windows Preferences and you can see TestNG here.
I hope you are done with the installation of TestNG in Eclipse. I'm Komal and I'll be helping you understand the various features that TestNG provides in Eclipse. So first of all, let us have a look at the outline of how a TestNG test can work. So first of all, we decide the business logic of our test. What we mean by this is that we choose the functions that we are going to test and then we insert TestNG annotations in the code appropriately. Then TestNG also uses a testng.xml file to provide certain data or certain information to the TestNG class, that is the TestNG test class. Then finally we run the TestNG class. So first let's understand what annotations mean. Annotations are basically words which are inserted with a preceding at the rate in certain places in the code, which modify the execution of the code in a certain way. We will understand this exact execution as we proceed. Before proceeding to understand annotations, I will show you an important aspect of running a TestNG class. I have prepared a set of TestNG classes over here, that is some classes over here which we will be testing with TestNG. So in order to run TestNG, we will need to include the library of TestNG. For this, we choose the project or the package that we are going to use, and then we right click on it, then we go to build path, then we go to configure build path. So here we open the libraries tab, then we go to add library and we choose TestNG, next, finish. So now we can run TestNG. So for example, if I want to run the parameter.java class, I will right click on it, I will go to run as, and I will click on TestNG test. Before running this, let's understand what parameter.java will do, but even before that, let's proceed with the annotations. So the first annotation that we are going to look at is add test. This is the most basic and the most important annotation which is used in all classes that we test. So let's look at sample1.java. In this class, I have inserted an add test annotation before test email generator function. So this test email generator function is basically creating a random email generator object over here, and from this class I'm returning a certain email ID, and then I'm using the assert function, the assert class, to check whether the expected email ID is the same as the actual email ID. So what I'm doing is I'm checking if assert equals this email ID that is being returned from here is same as this email ID. So what running this function will do is it will simply execute this function, the function with the add test annotation, and provide us with a report of the function. So let's try this out. I'm right clicking on it and I'm going to run as, and then I'm clicking on TestNG test. So as you can see is an output is provided in the console. So it says that tests have been run and there are 0 failures. So this is a console output, and to get a better view we will click on results of running class here, and this shows green ticks which shows that this test has successfully executed, this test has passed. So if I change something over here, if in case the email ID does not match, for example if I remove com and then I run it again, let's see what happens now. So we see that there is one failure over here, and in the results we can see that the failure has occurred in the test email generator class. What is the cause? So it says that there is an assertion error expected is this, but we found this. So we can see that TestNG gives quite a clear report of the failures. Let's look at the next annotation, which is the before method and after method annotation. This is quite self-explanatory in the sense that all the methods that are there in the test classes, so if we mark a method by before method, then that method will be executed before any method is executed. Now that may sound complicated. Let's look at an example to understand this better. So in this sample3.java class, I have written some functions. This is a test. These two are test groups. I mean to say test functions. When I write an add test annotation before a function, it becomes my main test function, right? So I have written more functions which are used as before and afters. So for example, this function before method, I have written a before method annotation before this method. So before any other method is executed, that is before any test method is executed, this before method will be executed, and after method will be executed after this test is executed. So let's understand this better by executing this. Now, okay, let's first make this clear that I am printing out the name of the function inside the function. So the final output will show us the basic execution of the program, that is the sequence of execution of the functions. So I'm running the sample3 Java file with TestNG, and in the console, let's see what happens. So this gives a quite a clear view about the sequence of the functions. First of all, before class is executed, before any other class is executed, the before class method will be executed. Let's look at where the before class method was. Here is the before class method. So I've added in before class annotation over here. Let's make it clear that the name of the function is not necessary before class. As long as I'm adding a before class annotation before this, I can name the function any way I want. So first of all, the before class is executed. Then we have before groups. I'll explain this later. Then we have before method. So before a test method is executed, that is the run test 1, this one, before method is executed, and once this is over, after method is executed. Then again we have after groups, then we have before method again, because a new method is being executed. So before this method, before method, and after this method, after method, and after everything, all the class methods are over, after class. And then after everything is over, we can see that this function is this class has been executed. As you can see in this sample2.java function, we have before suite and after suite annotations also. In order to understand this, we will have to execute a lot of tests. So first let's proceed to other annotations. We have looked at before and after method, and also before and after class. That is, if we have many different classes in a bunch of tests, then before class method will be executed before any class is executed, and after class after every class. Then we have before suite and after suite. Then we have before groups and after groups. Okay, so let's understand the concept of groups. So I can have many tests, right? For example, I have two tests in this function, these two. These are just two, but I can have more than two tests. I can have 10, I can have 15, I can have 500 tests too. So I can make groups of tests. For example, I have added the run test 1 function in the group called shopping. So how we can make groups is, after the add test annotation, we use the groups argument. We write groups equals to, and we write the name of the group that we want to add it to. So for example, if I want to make another test which is a part of this group, I can write another function, and then I can write add test and write the same thing over here. So the next time a before groups or after groups annotation is added, what happens is that before every group is started to execute, this before group function executes, and after every group, after group annotation while the function can execute. So as you can see, these annotations are quite self-explanatory. Then we have parameters, and we also have data provider. Now these are important concepts of TestNG. Let's understand these by example. Right. So we have parameter.java. Now, for every function, we might require certain variables, and a simple way to pass values to variables is by having a main function, and in that main function we can pass values to these functions. But TestNG provides these features of parameters and data providers, wherein I can add certain variables, I can send certain values to these functions. So there are two ways. One is data provider and another is add parameters. Add parameters is an annotation, data provider is an argument. So first let's understand data provider. Now when I write data provider equals to dp, what this basically means is I have defined a function called dp which acts as a data provider for me. Now data provider is essentially just a function which has this annotation add data provider added at the top of it, and then it returns an object which consists of certain values, and these are basically the data which are used inside this function f. So for example, in this function dp, I am returning objects 1A and 1B. These are two different objects, and I'm returning these two objects. So what this will do is, when this f function is executed, it will take both of these values and basically run two times, once with the first object and then second time with the second object, and each time it will execute using this data provider. Passing values to certain arguments is used by using the add parameters annotation. So here is where the role of an XML file comes into play. We can pass the value of this number variable through an XML file, which will further be used inside the function. So let's understand how an XML file can be generated. As you can see, I've already generated an XML file, but for your understanding, I will be creating it again. So for example, I want to create an XML file for the parameter.java function for the Java file. So I will first run it as a TestNG test. And as you can see, inside this, it has skipped the parameter in test function, which is this function which basically requires parameters. Since no parameters have been provided, it has skipped this function. So let's provide it with parameters from the XML file. Now since I have already run this, I will first refresh this, and then in the test output folder I can see index.html, and I will open it, and in the left tab over here I can see a link to the XML file. When I click on it, I can see an XML file generated over here. Now I will first copy the contents of this file, and then I will paste it inside this file that I have already created. Now I will add certain things inside this. I will add a parameter tag. First of all, I will use a name for the variable, and I can see that the name required is number. So I will write the name as and then I will provide it with a value, let's say 10, and I will save this XML file. Now in order to use these values for this function parameter.java, I will have to run this XML file. So I will right click on the XML file and run it as a TestNG suite. Oh, as you can see, an error has occurred over here because I spelled parameter incorrectly. Okay, let's do it again. Then I'm running it again as a TestNG suite. And now, as you can see, the parameter function has executed successfully. For a better view, let's look over here. As we saw, the data provider functions were already being executed properly, and now the parameter in test function is also being executed, and it is using the value 10 as we had passed through the XML file. So that was the parameter annotation. We can now look at other features. First such feature is ignore test. What basically happens with the ignore test feature is that I can ignore the execution of certain tests. That is, if in some line of execution I do not want to execute certain tests, I can simply choose to ignore them. How does this happen? Let's look at this test ignore.java file that I have created. In this file, I've added this argument enabled equals to true. What this means is this function test2, this test will be executed. If I write enabled equals to false, then this test will not be executed. Let's check if this actually happens. So I'm running it as TestNG test. As you can see, it has run only two tests, that is the test 1 and test 2. Let's just print so that there is no doubt. We're all set. Let's execute this once again. So as you can see, it is only running test 1 and test 2. So suppose I do not want to execute test 2 and I want to execute only test 3. Then I will set the enable as false for test 2 and I will set it true for test 3. Let's run it again. And it is clear that test 1 and test 3 have executed. So this was the test ignore feature. Then you have timeout. There can be certain functions or certain tests that will take very long to execute and that will hinder the progress of other further tests. So in order to limit the time that a function or a test can take, we can use the timeout feature. So I have used this in this test timeout on Java file. As you can see, I have added a parameter over here, the argument over here of timeout, and I've set it as 5000. By default, this value is in milliseconds. So basically, I'm waiting for a timeout of 5 seconds. I have made this sleep for 4000 milliseconds. That is, no, I'm so sorry, this is for 4000 seconds. So what will happen over here is, it will time out after 5 seconds. And over here, I'm entering an infinite loop and I'm making a timeout of 1 second, so this means that this test should fail. Okay, let's run this and see if this actually happens. As we can see, it is waiting for 5 seconds and finally it gives an output that this test should pass function has passed and test this should fail has failed. And we can see a better view over here. This function has passed, this function has failed because there was a timeout of 1 second and there was an infinite loop over here. So as we can see, this feature of timeout can be used to detect infinite loops. If there is an infinite loop in a function, then if we have set a timeout, then that function will fail. And as we can see that this test has passed because it has slept for 4000 seconds, I mean to say 4 seconds, and there's a timeout of 5 seconds, so it is not executing, it is not exceeding the timeout, and hence this is executing successfully. So this was the timeout feature. Then we have the dependent test feature. Next feature to be learned is the dependent test feature. Now this is a new feature and an important one because this is something which was not present in JUnit and is a special edition in the TestNG tool. So in order to understand the dependent test feature, I have prepared some classes over here. Now let's start by understanding what this app is trying to do. So the first method over here, it says that it depends on groups, deploy and DB. Now the dependency is shown in terms of two arguments. One is depends on groups and another, as we can see over here, depends on methods. So you can write the name of either the group or the method which needs to be executed successfully before this function starts to execute. So for example, before method 1 will start to execute, it says that deploy and db, both these groups should be successfully executed and then only this will execute. So let's look at deploy and db. As you can see, db is this group which is basically the init db function. And now we can see that it also depends on the group deploy. So basically the deploy group has to execute successfully before any of this executes. The deploy group is basically this class test server. So only when the test server successfully executes can the database function, and only when the database functions properly can the method 1 execute. So this is the dependency, and in such cases the dependent functions are used. Let's execute this and see what happens. So I'm right clicking on dependency package and I'm executing the entire package together. And as you can see, all the tests have successfully run because there are no errors. In the sense that, first of all, the deploy server executes successfully, and then since deploy backup server is dependent on deploy server and it has successfully executed, then this also will execute successfully, and so even initdb will execute successfully, and finally even method 1 will execute successfully. Now to check how this may fail, let's say deploy server is not able to successfully execute. Suppose I will do an assert over here. Suppose I try to equate true with a false. Oops, need to import the assert. Alright, done. So this will make the deploy server fail and hence all the tests will fail. Let's see if this actually happens. So I first run it as TestNG test, the package, and as you can see, tests have been either failed or skipped. So first of all, we see that the deploy server fails because of the assert function. So now this is what happens when a dependent method does not work. For example, the deploy backup server function is dependent on the deploy server function. And since the deploy server function fails, the deploy backup server is skipped, as you can see in the console. Basically, there have been 3 skips and 1 failure. The 1 failure is the deploy server and 3 skips, 1 is the deploy backup server. Second is initdb, and finally the third is method 1. So this is how the dependent methods work. To understand this feature, let's look at an example. For example, I have this file over here, testexception.java. In this, I am doing a divide by 0, which generally gives an exception. So let's execute and see what happens. So we see that this test has failed because there is an arithmetic exception. Now TestNG allows me to ignore certain exceptions. That is, I add this argument expected exceptions, and I've given that arithmetic exception can be ignored, right? So since arithmetic exception is expected in this case, if such an exception is thrown, this test will still pass. Let's see if it works. So when I run it, we can see that now these tests have passed. So even though there is an exception, since I've added this expected exception argument over here, this test will still pass. So that was the expected exception.
Basic understanding of TestNG, let's move to a demo. In the demo, we are implementing a basic calculator in Java. The calculator implements all the basic functions like add, subtract, multiply, divide, power, root, percentage, square, cube, square root, sine, cos, tan. So you can see that we are providing the data with two main functions. Data provider equals to simple and data provider equals to data provider. The difference between these two is for the functions where two inputs are required, number 1 and number 2, we have used simple data provider. Int expected is your expected output. Sorry. Int expected is your expected output for the calculator function, for the functions in which only one integer, one input is required. The data provider is used, and int expected is the expected output. Let's first see how we have implemented the data provider function. The data provider function, data provider, as you know, the data provider returns an object. So the data provider function matches the method name of the function. So if I am asking the inputs for square function, it will check the get name is square, and then will give the result. The result here, we are using two input test cases. 2 is my number and 4 is my expected output. Similarly, 4 is my number and 16 is the expected output for squaring. Likewise, we can include as many test cases as we want. So is for cube, square root, sine, cos and tan. You can see for sine, cos and tan we have used we have used we have used double as the inputs. In the data provider function simple, there are three inputs. So the number 1 and number 2. If we are going for add, then it will add number 1 and number 2, that is 1 plus 1, and the expected output should be 2. Similarly, we can include as many test cases as we want. Here below are the basic functional annotations of TestNG, like before groups. As you know, before groups is after and before each and every group. The group we have implemented in this demo is the trigonometry group. So all the sine, cos and tan functions are assigned with a group, trigonometry group. So in the case where we only want to test these groups, we can run a test case and test them. The before and after group function will show us when these test cases, the result of these test cases. It will print trigonometry group started. Before and after groups are more used in the functions where we want to give a special input to a special group, or want to do some functionality for some special group. So if we wanted uh, to to do something before executing this particular group trigonometry, we can do this inside this. Or we wanted to do something after executing all the test cases of this particular group, we can add the functionality here. Before method and after method function, as you know, are executed before and after each and every method in the file are executed. So this function will print before method and after each and every method. Also, if some method includes system output command, that is print command, then those commands will be included between this before and after method function annotations. Before, as you know, before class, after class, before test, after test, and before suit, after suit will functionalities will be implemented as they are supposed to be. Next, let's see this thing. Depends on method. As you know, dependency, we have already seen how dependency works in TestNG. So depends on method subtract means this line will only print when the subtract method is successfully executed. So all the test cases of the subtract method should pass for this line to print. Similarly, depends on group trigonometry. So all the test cases of trigonometry groups, that is sine, cos, tan methods, and all the test cases for each one of them should pass for this statement to print, or this test case to pass. Now let's run our test case and see what happens. I click on calculator.java, go to run as, and click on test engine. So here is our report. The before suit, test suit, before class, before method. Now add to. So when we see our add function, we have a system.out command add plus answer. So before this method is executed, after this when this method is done, like in between before and after this method, add to is printed. Similarly, add 400 and before and after method for each and every method. Multiply, subtract, divide, and by at the end after class and after test. And after the whole test suite is implemented, you you can see after suite is printed here. So as we have seen, suite prints when whole suite is implemented. Now there we run 27 test cases, out of which four cases failed and two skipped. To have a clear look of this, let's look here. Here we can clearly see which test cases failed and which test cases passed. On a test fail, if you want to know the clear reason for a failed test case, you can go here to your report. Here you will see the past cases and the output. Past cases, the output, the, the case value, sorry, the test case value, add 112, add 200, 200, 400. These are the values we gave to the data provider. Now the failed cases and the reason. Assertion error, accepted this but found this. This was supposed to be an error because we gave 0 0.5 as the expected input, but actual our like is this 00001. Similarly, sign is an error. Here you can see the reason. Subtract is an error. Now, why? Java here, let's see the reason for failing of this. Assertion error, expected true but found false. Now, what is this error? Let's go to our subtract function. Here we have seen that assert true, number 1 should be greater than number 2. That is, for a positive subtraction, we need number 1 to be greater than number 2. This is a this way we can check if negative numbers are not there. So, if in my data provider, let's go to my data provider of the subtract function. Here it is. I change this value to 300 and this value to 200. This test case should pass. Let's see. Now the tan error, expected value is this, and skipped in it. Let's see this function method in it. Here is this our init. The method failed because skipped because it is dependent on method subtract, and as we just saw, it failed. So now that we have changed the values, this test case should show pass. Skipped initdb. Initdb is again our dependency method, dependency test, which is dependent on group trigonometry, and we just see, like we just saw, that many test cases of sine, cos and tan failed. So we can do is change the expected value of these and have let these test cases pass. We'll go to cos, data provider for cos, and change the value from 0 0.5 to, now the sine value. Let's go to science data provider, which is here, and change the value from 0 0.5 to it's supposed to be exact value. This is just the calculator functionality, and it's nothing related to TestNG, but since we need to pass the test case, so we can see a good report, we are doing this. The tan value from 0.00 to its precision value. Before running this, let's see the HTML report of the test engine. We will refresh the package, and in the test output we can see the index HTML. This is a very good functionality of TestNG, where we can see the report of each and every, we can generate HTML report of each and every test case. This is a clear report, so we can like print this report and use it here. Failed test case 27 method, 21 passed, 4, 4 2, 2 skipped and 4 failed. And here is the XML file for this report, for this test calculator.java testng run. We can we can copy this XML file and create our own XML file for running the test cases. Since this functionality is not required and we have seen this working, so we will not implement it here. Now that we have implemented made changes in our Java calculator.java file, let's run it. Run this testng.test. And here you will see all our test cases are passed and none test case skipped. No test case skipped. In the console, let's see if all the functionalities are printed. All trigonometry test cases passed. This was a dependency test, as you remember. Subtraction passed. This was dependent on method test, as you remember. All the test cases passed. So that's all for the demo of TestNG. Thank you.
So some of the pros of TestNG tool I've listed over here. First of all, as we saw in the data provider annotation, XML files can be used for test configuration and test route definition. And that was just one small example. And as we also saw in the demo, we can choose certain groups to execute from the XML file. So basically the execution of the tests can be modified as per our wish from the XML file, and instead of going through the entire code, we will just be able to modify the execution from a small XML file. Then we also have dependent methods which can be used to check certain dependencies. If certain groups, certain methods are dependent on other groups or other methods, then their execution can be controlled using the dependency feature. And the test groups are also an important feature for TestNG. We can choose to execute certain groups, and this can be used for various applications which were outlined in the demo. And parameterization is also an important feature. Data driven testing, as was used in the data provider feature, and multi-threaded execution. This basically depicts that parallelly various tests can be executed. That is, we have defined various methods which contain the add test annotations, and all of them can be executed in parallel. And definitely good reporting, because we can observe the reports in through the console, through the format that we saw in Eclipse, and also through HTML files. Some cons that we observed was there is a lack of proper documentation online, and therefore it is very hard to understand this tool, and there is also quite a decreasing popularity because of this. And also we observed that it is not compatible with certain versions of Eclipse, although this does not matter because it works with the latest versions, but still. Thank you for watching this tutorial. We hope we helped you in understanding TestNG and its various features. We are providing you with the contact information of one of us in case you have any further queries. We would like to thank our instructor, Professor Saurabh Tiwari, for giving us this opportunity to experience this new tool and help the community also understand this better. Thank you.